Hi and welcome. This video is designed to be watched in conjunction with my Prolix Sage blog. The blog is a record of my journey learning object-orientated programming. I already have experience in procedural programming using C assembler and ladder, and I thought it might be fun to record my first object experiences pretty much in real time. Hopefully by recording my journey, mistakes and all, it will help you with yours. The first thing we'll do is create a C# console app using Visual Studio. I'm assuming you already have some of the basics, but if not, there are lots of resources out there to help you get started. When you start Visual Studio, click the button to create a new project. If it's not already listed down the left, start typing console in the drop-down, and when it appears, select C# console app. When you're asked, give your app a name and then click create. It's important to say at the start that this blog post is not a tutorial. It's more my internal monologue as I'm trying to understand object-oriented programming for the first time. That said, hopefully my learning experience will be useful to someone else in a similar position to me. I'd like to start by exploring what's a class, what's an object, and what's the difference between them. In a lot of the videos I've watched, the two words are used interchangeably, but I want to understand what each term really means. The best description I've found is that a class is a blueprint of what an object should be. We'll worry about what objects are a little further on. A class, or blueprint, is the set of instructions that tells the computer, or more accurately the compiler running on the computer, how to put together a particular object in its memory. Once you have written a class, it can be used again and again, to make lots and lots of autonomous copies of the same object. I've used the word autonomous on purpose. I'll come back to that later on when I write some examples. The first thing we have to do is remove the default code created by Visual Studio. Let's get started and create our first class. Like pretty much every other example on the internet, I think we'll start with an animal class. If you read the post on my blog for this article, you will see that there's lots of problems associated with the animal class when used in this simple form. For now though, it's a good enough example to see how a single class can be used to create any number of objects. So as you can see, we have typed in the keyword, class. Then we gave the new class a name, followed by a pair of squiggly brackets. These squiggly brackets act as placeholders for the code that defines what the class is to do. It turns out that every class needs something called a constructor. The constructor is something the compiler uses each time a new object is created. Visual Studio can automatically create the constructor for us. Click on the little light bulb and then select Generate Constructor from the drop-down. You can see that Visual Studio has created some default code, which is fine for now. There seems to be two key parts to a class. These are known as properties and methods. For now we will define a property as an attribute or variable which is held within an object. These variables can be made available for code outside of your object to use if required. The general consensus seems to be properties are named after nouns or noun phrases, for example a type of animal, or an animal noise. This gets more complicated when we start discovering accessors and talking about scope, member fields and encapsulation, but for now this definition is fine. The second key part of a class is a method. A method is a block of code that belongs to your object and tells your object to perform a certain action. The special thing about methods is that they can be called from code outside of your object. Methods tend to be doing actions and are named as verbs or verb phrases. For example, make noise. Your external code can call this method. When called, your animal object will execute the code stored within make noise. Don't worry if it's getting a bit complicated. The next thing we will do is to make a number of animal objects from the animal class and get each animal to make its own noise. Hopefully it should then all become clear. We now have the class that describes an animal. The next thing to do is to use it to create a number of different animal objects. For each animal object, we need to tell the compiler to allocate a variable name, and a new space in memory that will represent that particular object based on our class. This is enough detail for these fundamentals. In further episodes I think I'll come back and investigate what happens behind the scenes. I recently watched a video on YouTube where Uncle Bob Martin explained how memory is actually allocated, and the mechanics behind it. For now it's a bit too complicated and would just muddy the waters. So we now have 3 distinct autonomous objects, the dog, the cat, and the monkey, all based on our animal class. The 3 objects are all treated as separate entities within the computer's memory. We can see this by setting the properties of each object in turn, and checking that it doesn't affect any of the other objects. We can now call each object's make noise method, and in theory each object should exhibit its own behavior. We can test how this works by clicking the Run button at the top of the screen. Visual Studio compiles and executes the code. The make noise method that we wrote code for, just once in the class, is executed first for the dog, then the cat, and finally the monkey. You can see that this single method, written once, produces 3 different results. One thing that has become apparent is that modifying a single class can affect all the objects based on that class. This seems to have both advantages and disadvantages. One advantage is that you can quickly add new code into a class, in this case a new property called fur_color. Once added to the class, all the objects that were based on the class now have that new property. So now, dogs, cats, and monkeys all have a variable that holds their fur color. Likewise, if we find any bugs, fixing them once in the class fixes them and all the related objects. So this is the end of my very first attempt at using object-oriented programming. I created a single class and used it to create 3 individual objects that share some common code. Even as a newcomer to this method of programming, I can see things that cause me to be a little uncomfortable. In my mind, an animal is just an abstract construct. It has no basis in reality. What I mean is that in real life there are cats, there are dogs, there are monkeys, but there is no such thing as just an animal. It's not a thing that ever exists in its own right, but technically we can create an animal object in our code, which doesn't seem right. If we change code in our class, then every object that came from that class changes. In some cases this can seem a good thing, but in reality each object we create, whether dog, cat, or monkey, should have the ability to have its own method of making a noise. Thankfully, all those years ago, people much cleverer than me had similar thoughts, and designed object-oriented languages to negate these type of issues. In my next post I will be introducing myself to abstract classes and overriding methods. One last problem I haven't quite come to terms with is this hierarchy structure. It strikes me that if it isn't well thought out at the start, it can cause major problems later on. For instance, our objects, dog, cat, and monkey, are created directly from the animal class. We haven't considered amphibians, birds, reptiles, or any other kingdom dwellers. In the real world this isn't right. We need to consider the whole system of categorization from kingdom through to species. I'm not sure object-oriented design can fully resolve these particular issues. I suppose it means that you, the designer, have to think very hard about what objects actually look like before embarking on a project, rather than just winging it as you go. Well, I hope this little video has been of some use to you. If it has, then please take a look at some of my other articles at my Prolix Sage blog. Each post is written from the perspective of someone new to this world. The theory is that if we go in with an open mind and consolidate small steps, then we will develop enough fundamental concepts to start to grasp some of the more complicated ideas. Once again, thanks for watching.